Morning, good afternoon, and good evening, depending on where you are. And welcome to the Nautel webinar on Push Radio, a new concept in content distribution. I'm Chuck Kelly in Halifax, Nova Scotia. Very proud to have you along with us today, and also very proud to be sharing the spotlight here with Mr. Eugene Novacek, the president of ENCO. Good afternoon, Gene.
Hi, Chuck, and hello, everyone.
Glad to have you with us. So here's the agenda of what we're going to talk about today. We're going to talk about the traditional studio to transmitter model, new enabling technologies, things that have changed from a technological standpoint that allows things to change, the new push radio model, give you a definition of who we perceive the target push radio client might be. We're going to talk about how ENCO fits into the whole concept of push radio. We're going to talk about some specific benefits of push radio. Then we're going to talk about the future and the configurability, and really we're going to ask for your feedback about how push radio could best be used in your environment to make better broadcasting and to do it less expensively. And then we're going to take your questions. One of the things that's really nice about the webinar is that there's a little bit of software on your screen there, and you have the opportunity at any time during the webinar to type in a question for us. And at the end of the webinar, Eugene Novacek and I will attempt to answer all the questions. Now, last time we did one of these, there were so many questions. I think we weren't able to get to them all, and we had to answer some of them offline, but I guess that's the price of success. Nobody wants to spend the entire day here. So let's talk first about the traditional studio transmitter model, how it traditionally works in radio. So traditionally you have a studio in a radio station, and you have your centralized audio content, and these days, of course, we use automation systems either in a live assist format or in a full automation format. And then somehow that gets to the studio to transmitter link, whether that's microwave or satellite or equalized phone lines, and it gets to the transmitter. And the transmitter puts that on air. And that's fine, but there are a couple of limitations. First off, and let's talk about the roles of everything. So the studio's role is to hold the mass storage, it's to create and import new content, and to manipulate the playlist of things that you're going to play. The STL role, by definition, I guess, Studio to Transmitter link, is to convey the audio content to the transmitter in real time. And then the transmitter's role is really simple, and that is to air the incoming audio stream to the public, to make it into high-power RF and put it through the antenna and send it out to the world. And so that's the roles of each of the pieces in our traditional model. There are some problems with the traditional STL. Number one, microwave STLs tend to be costly, and these days there's so much potential for interference and blockage from new buildings that they can be troublesome. Metro areas, the frequencies are congested, older analog STLs may compromise audio quality, and in general, STLs tend to be a single point failure. That is, if they go down, you're off the air. And frankly, my experience in my 40 years of being involved in radio is that the STL is oftentimes the least reliable part of the entire station system. Telephone lines as an STL are getting increasingly difficult to obtain. You listen to the message boards these days and you hear people talking about trying to find some way to get an equalized line out to here or there, and the telephone companies just don't want to hear about it anymore. It may compromise the audio performance, and they constitute a substantial monthly expense. So the microwave STLs may be just simply a capital expense and may not have significant running expenses, but telephone lines you pay every single month. Satellites are very expensive, but they handle large geographic distribution well, and they suffer from sun outages in general. So you're going to have, for sure, at least a short term, depending on the size of your dish, outage from satellite at least once a year. Now let's talk about what's changed in the world since that traditional model was created. The microwave STL has been increasingly taken over in some fashion by the internet, and the transmitters have become intelligent transmitters, and I'll explain that more in a moment. And centralized storage, well, in terms of the IT world, centralized storage has tended to become more distributed storage because of the reliability of having distributed storage. So we take these ideas and we put the things together. Now, what is the problem with using the internet as an STL? Well, first off, it's got a big benefit. It's very inexpensive, and many studios and some transmitter sites already have high-speed internet available. But it tends to be unreliable for long-time, real-time delivery of content. But it can be very reliable for non-real-time file delivery. So that's how we see the internet as an STL. Let's talk about intelligent transmitters. All of the Nautel transmitters these days, pretty much all of the Nautel transmitters these days, are based on the AUI, and there's a certain amount of real intelligence that comes along with this. For one thing, they're all IP connected, and they have the ability to monitor. They've got a web server built inside, so you can monitor the transmitter through the AUI, and you can even send content to it via IP. So, for instance, Livewire, Shoutcast, Icecast, all of that content can be sent live in real time to the transmitter via IP. In addition to that, in these transmitters, and some of these, this feature is just being released, but this is new news. This is exciting news. Local content storage, the ability to have a USB port on the transmitter where you can plug in your own USB storage, whether it's a big memory stick or it's a USB hard drive that's terabytes large. The other day, I bought at one of the local stores here, I bought a 64 gigabyte memory stick, flash drive, little USB dongle thing, and it was $12. And I thought, my goodness, how the world has changed. Anyway, one of the other features, so that USB storage in the transmitter gives you the ability to plug in a whole bunch of audio files in that USB storage, and then there's the ability within the transmitter to create a playlist and play those off. And those files could be in WAV format, or they could be in MP3 format, or what you like. And that, you know, the fact that we've included MP3 format does not in any fashion indicate that we suggest using MP3 on air. It's just if you happen to have that and they're certainly available in an emergency situation, sure, put it on air. But these days, with the cost of storage, a WAV format file is certainly preferred because it's better audio quality by far. We can also have the ability through the IP port in the transmitter to FTP new content to that USB storage. So if I had another cut I needed to send out, I could send it by FTP. It would store it on that USB device, and then I can remotely make changes in that playlist so I can take in that new content. There's also a built-in scheduler that works with an NTP client, so very accurate decisions can be made on the basis of time. And there's also the optional audio processing built in, which is the Orban inside. So all of these kind of come together in all of these products, the NX series high power medium wave, the VS series low power FM, the NV series HD radio and DRM compatible FM transmitter series, and the new NV light super high efficiency higher power FM transmitters that go from 3.5 to 88 kilowatt. All of these transmitters have this basic functionality built into them. And what we found is that the original idea was that the USB audio playout would simply be for emergency purposes. If your STL were to fail, the first thing it could do is to go out and find your Icecast or Shoutcast stream and put it on the air, and that would work as well in case of a failed STL. But if that failed, suppose you have a brownout or a blackout at your studio, you've got nothing coming out of the studio, you could have some backup canned programming on a USB stick, and the transmitter could be programmed to automatically switch over to that and start playing content off the USB drive. So that was the original content. What we found is that there were people that didn't want it to stop there. They actually wanted to use the USB playout system as the primary storage method. And that's where all of this idea for push radio came from. So what we said is the low-cost internet could replace the STL if it's not pushing out real-time audio. Instead, it's sending out files to the transmitter. It's reliable for that. And we replace the transmitter with an intelligent transmitter that has all these features, and then we take and change and have distributed studio content at the transmitter in addition to the localized or centralized studio content at the studio site. So all of this is made possible because of these disruptive technologies. So let's talk about how you can take all these things and kind of put them together. What this allows us to do is to have local play out of stored content, which could be limited to when you have either an STL or a studio fault condition. So that's an emergency situation. Or you could have live broadcast via conventional STL or IP stream, switching to stored content during specific day parts. So not necessarily an emergency, but not 24/7, 365. Or you could have most of the programming coming from local content with switching to an IP stream for newscasts or live call-in shows or sports events. That's also possible. All of this is doable today on a manual basis within the NV Lite and the VS series transmitters, and soon the newer transmitters, the NX transmitter and the NV series transmitter will also have all this functionality in the future. So one of the things that this provides is one of the strengths, one of the basic strengths of radio, and that is localism. We can afford to do things and target our local community much more so than television can, because the cost of production is so much less. We can cover a news event, we can be a part of a local community. And satellite distribution, if you're a network that's got 100 stations across a country and you're using satellite for program distribution, that's a pretty appropriate method of getting the content distributed in live form. But the negative to that is you give up to localism. The weather forecast for New York City is the same as the weather forecast for Los Angeles. And the local commercials don't exist, and the local news doesn't exist. So with the push radio model of actually sending out content to the transmitter and playing it out locally, you can actually localize because you can push out different content to the different transmitters in the different regions. Now, what I have described so far is what I'm calling push radio manual. This is the concept in which we're doing all of this via the AUI. We're uploading content to the drive, and we're changing the playlist on a one-to-one basis. And that's pretty easy to do on an emergency basis, or when you've got one or just a couple of transmitters. But what if you've got 100 transmitters? How could you possibly keep all the playlists up to date, make sure all the content is out to those sites? It's not possible. So we started wondering, how in the world what type of software would it take to be able to automate this process of making sure all the content is in the stored drives at the transmitter site, and at the same time, how would we assure that the playlists are all right? And dreaming here a little bit, how could we bring back the as-played log for reconciliation in the station? And we decided the best way to do that was to utilize software that pretty much already existed, and that is the mainstream automation software. And one of the most innovative companies in this industry in the automation side is Enco and Gene Novacek. And we talked to Gene, and he says, oh yeah, he says, this could be done easily. In fact, what you're really doing is, instead of controlling sound cards, you're controlling individual transmitters via IP. So Gene, why don't you take it from here and start explaining the process and what we've changed and how this all fits together.
Okay, thanks, Chuck. Can you hear me, first of all? I
hear you perfectly.
Great. Thanks again, everybody. Chuck just said the best way to visualize this, in that Enco now treats the transmitter as a remote sound card, but a really smart remote sound card that has local storage right on it. It's like having a sound card with a hard disk or a thumb drive right on it, where we can remotely tell that sound card to play a very specific file that's stored locally, instead of having to stream that file through the STL, which Chuck very nicely alluded to, is that it's, could be unreliable, whatever. So what we're doing in Enco with our DAD automation product, DAD is digital audio delivery. So when I say DAD, I'm not talking about my father. I'm talking about our automation product. So I'm going to go through a little bit of DAD. I'm not going to do a full demo, but focus on how Dad talks to a VS transmitter using this push radio technology, and not in a manual mode, but in an automation-controlled mode. So let's start off by doing, Chuck, give me control, if you will.
Oh, okay. Well, let's go through the slides, and then I'll give you control at the end of these slides. How's that? Okay.
Oh, okay. You want to go and finish the slide?
I'll go ahead. I'll go ahead and move the slides for you. You can just work through these slides, if that's all right with you.
All right. Well, I'm already done with that. I'm going to cover everything that's in that slide coming up. So
all right. So go ahead.
You can kind of skip through these.
This is the DAD basic interface.
Right. This is our an on-air interface, a very small part of DAD, which I'm going to show you live in a moment. We just wanted you to have some idea of what screens were about to be shown. So
I think the fun thing about this, Gene, is that people who use DAD today would recognize this screen. What they'd be surprised to see is up here in the upper right-hand corner, they'd be surprised to see the transmitter AUI showing up in the DAD player.
That's right, and we're going to see that live in a moment.
Okay.
And now what we did to make DAD do this, rather than modifying DAD, which is a huge, million-line program, we created an interface that acts between DAD and the push radio technology. So here's a little, we call them blue apps because they're always blue and they always look like this. So this little blue app here is called Push Radio, and it just listens to DAD for control commands. It monitors DAD playlists for modifications, for new sound, new songs, things like that. And it listens to the VS transmitter for things like, I'm now doing this, I'm now doing that, here's an as play log. So it's just a communications interface between DAD and the transmitter. Now, the transmitter kind of looks like an FTP site. We're actually using the same kind of upload technology that YouTube uses called WebDAV. So it's much better, more efficient, more reliable, more secure than FTP, but it is a form of FTP transfer. And then right here is the portion of the AUI itself that lists what DAD is doing to the transmitter. It's creating playlists, it's adding content, it's modifying the content within playlists. And you're going to see this live in a moment as well.
Let's go ahead and do that, Gene. I'm going to go ahead and switch control to you, and you can show your screen and walk people through the DAD itself and the interface.
Okay.
So you are now the presenter.
All right, and you're should be seeing the AUI interface. I have a transmitter right here in the lab, a VS300. I don't have an antenna on it, so I'm not going to output anything. So it'll always say 0 watts, so I'm not actually transmitting to anything. But here's the typical AUI, and we're going to get right into the guts of the push radio portion. So I'm going to menu, playlist, and here are what me as the automation guy is concerned with. On the right side here, this is the storage. This is what's on a USB drive connected to the VS. So there's just some MP3 files there. On the left side, very leftmost, I have 3 playlists. They all start with PR for push radio. That was just something that I wanted to do so I could keep track of my push radio playlists. So there's a PR test, a PR long, and Proclaimers is a group, and I have a Proclaimers playlist, so it showed up because it's got a PR in the front of it. If I highlight any one of these playlists, it shows me in the middle what part of the files that are on the USB drive make up that playlist. So the PR long playlist has some NPR stuff like All Things Considered, some promos, Day to Day, things like that. So some of these are very long format. This All Things Considered entry here is a 1 hour long program, followed by a promo, followed by another hour-long program, by another promo, and then another hour-long program. So this playlist of seven or 8 events is at least 3 hours long, if not more. So there's really no limit to the size of things. This handles this quite well. And as Chuck alluded to earlier, rather than streaming the All Things Considered from NPR through your station back through the STL to the transmitter, you could download a copy of that file in non-real time through an internet connection and then play it later. You could do it as a delay, or it could just be in there as an emergency. So in case the STL goes down, you have the current show or the current All Things Considered or whatever it might be ready to air. So keep in mind that there are these 3 playlists in here, and that's all that's in my transmitter right now. So I'm going to switch over to the Blue app, and now you see a live version of the push radio app itself. And it's really not meant for a human being to see. It's an automation thing that sits in background, but there are some test buttons and things like that just to see if things are working. So right now, I can look and see that I am connected. I can disconnect to the transmitter. I can start playing a default playlist, and you can see it started playing. You can see that because it says that it's playing playlist PR test, and it's playing that actual MP3 file right now. I can stop it, and it stops. So I'm remotely controlling via a couple test buttons VS transmitter. I can go get an as play log, so now I have a copy of an as play, and an as play might look like this. This is actually the as play log that I stole from Chuck's transmitter slightly earlier today, about an hour ago. But you can see it keeps track of, to the millisecond, what's going on, when it aired, exactly date and time, how long it played, the name of it, where it played, things like that. So this can be used for, in the case of music, for paying royalties, BMI, ASCAP, whatever, or more importantly, for doing billing for commercials. So if a commercial aired in this manner, we could actually now tie that back into a traffic and billing system to do commercial billing and invoicing.
And that's already a function of the DAD software. In other words, you have the capability of taking in this log and then sending out the songs to the music and music scheduling software, or sending out the traffic and billing information for the commercials that played, and that's already part of DAD.
Yes, correct. In fact, what we do with this XML file from the transmitter is incorporate it into the actual DAD as play log system. It just logs it as a different player. There are many different players inside of DAD. You're going to see that in a few minutes. We just consider the VSs as remote players. And it could be one of them or 100 of them. You could have many translator sites, and we identify them by name or number and say, okay, this entry was played by VS 300-14. So we know who played it and when, and it can be, the billing can be done appropriately. So now I'm going to just make it I'm going to try something different here. Hopefully now you're seeing both the Blue app and the transmitter AUI. So if I stop it, you actually see the modulation let me go to the menu, probably see a little better here. Okay, so in the lizard view pattern on the bottom here, you can see that there's really no activity on the transmitter. When I start it, you can actually now see the activity there. So it's more than just a response in the Blue app. You can actually see the results through the AUI itself. So we are honestly connected to a VS and controlling it remotely. So we're pretty well done with the manual Blue app of what we're going to do with it. Now the rest we're going to do inside of DAD. DAD will use this Blue app, the PR app, to talk to the VS in a more automated mode than this manual mode we just did. So I'm now going to go to DAD. So now you're seeing just an empty DAD desktop, and I'll just very quickly show you a couple modes of DAD. For example, here's you might have these are called playback machines. I just popped up 4 playback machines. This could be 4 radio stations, or a radio station and 3 internet streams, or a national broadcast and 3 translator site regional broadcasts. These are all playlists. And when I play something, that's got a really quiet fade in, but hopefully here in the background here, this Boston music. Okay, so every one of these, could be playing at the same time, which on my speaker is not going to sound great, but you can run up to about 20 of these at the same time on a single DAD. You're not limited for, but this is just one mode of going. Some other live assist type features are array panels and things like that, where you can just have a button and it play something, or it actually even play a video. Some radio stations are now playing video files, like music video. So the audio is going out the radio broadcast of the radio transmitter or the internet streams, but now the music video portion is now also going out the internet stream. So DAD has that ability as well. Now, while we're in here, now we can pop up in a little internal browser, if you will, the AUI that we're talking to. So it's still playing from what we started before, and I can actually now bring up a little VS300 panel of control. So now I'm inside of DAD, and I'm going to hit this VS stop button in the upper right, and you can see the listen to pattern went away, the modulation went down. We've actually stopped this. And what it did was DAD sent a message to the Blue app that's running in background that told the transmitter to stop. And now I can say start playing from this particular playlist called PR Test. Now it's playing again. I can stop it and load a completely different playlist, like that long playlist. So now it's playing from a different playlist, the long playlist. And if I look at the Blue app right now, you'd see that it's responding back, telling me exactly what I'm doing. Now, if I go into the menu and look at the playlist, I still have the same exact 3 playlists. This is exactly what we saw before. Maybe a little harder to see in this compressed screen, but they're there. A slightly different configuration for DAD, very popular live assist and on-air interface, is called Presenter. So this is just another module within DAD. And again, I popped up the AUI in the upper right, just like the screenshot that Chuck showed earlier. And again, I can run the menu and go to Playlist and see the same exact 3 playlists. It's probably very hard to read, but on my screen it's fine. But for you, it might be kind of blurry. But anyway, what we have here is a playlist. So now it's playing this Proclaimer song and tells the jock, operator, presenter, what's going on. There's VU meters, countdowns, things like that. What's interesting here is that this playlist can contain more than just audio. It can contain exactly the same kind of control events that you see in this array panel. So here's my array panel with, with music videos and sound effects and all kinds of things. But here are some VS control elements. I can take and drag one of these things right into my playlist so that right after Cap in Hand plays, it'll issue a stop command to the transmitter. That could just as very easily be a preset command that says change the VS transmitter to preset number 14, which might be load a particular playlist, start playing, output a frequency, certain wattage, power levels, whatever it might, even an Orban processing setting. So
the other thing you could do with that, presumably, is that if you decided you had to have some elements in your programming which are live, it could be switching to an IceCast or Shoutcast feed and then airing that, and you would have caused the preset change to select that other input, and it would then begin airing that preset.
Exactly. This preset 14 is a command in DAD. That command could be a macro that says, yeah, tell the VS to do this, but also start the IceCast stream and change the router so that it takes the IceCast output and outputs it to the various places that it needs to go. So all I'm pointing out is that here's the first thing I'm going to be is a 3-minute song followed by another 3-minute song, but then a 0-length command and then another 0-length command. So the playlist can contain more than just audio. It could be commands as well, including VS commands, just as you see here. So that's it in terms of what we do here. Everything that we're doing and playing, whether it's playing in DAD or on a VS, again, is tracking in as plays, which we already talked about a little earlier. So now the last thing I want to show you is going to go back to kind of normal DAD. I mean, not that Presenter was not normal, it's just more of a very specialized interface. So I'm closing up some of these modules, and I want to create a little playlist and show you what's involved in actually getting the content to change on the VS itself. So I'm going to go into my, it's called Playlist Modify, so I'm actually going to create a playlist, and I'm going to use some very short sound effects so that you don't have to wait a long time for things to transfer. So I'm just going to grab a couple sound effects. So I just grab these 5 sound effects, and I'm going to save this. And as long as I save it the way I've configured it here as PR something, like PR short sounds, as soon as I save this, actually I kind of want to have you see this, but, well, it's going to happen so fast it's going to be tough to catch. But okay, so now on the Blue app, which I switched to, you can kind of see that it says it found a new playlist called PR short, and it found the elements within it, and it says it's preparing them. What it's doing is converting them to whatever format was desired, and then it will start transmitting them to the VS itself. So if we go now and switch over to the VS, at some point you start seeing the transfers go. And so I'm going to switch over to the AUI now. And I'm not seeing it yet, but that's kind of a letdown. Of course, it's during a demo, something's going to not be quite right.
But the idea here is that it is now managing sending not only the content but also the new playlist to the transmitter. And then all you'd have to do is to select that and tell it to play.
Right. And I don't know why there's a delay here, but it's, it's... Oh, okay, they're starting to go now. I'm seeing them now in the... What screen do I have you left on? The AUI, right? Yeah.
Right, I'm on the AUI Playlist Manager.
Well, I can see the songs transferring over.
Yep.
And I see them showing up, but I just don't see the playlist yet. The playlist is the last thing to go over, and then,
right.
So we eventually see the PR short. And Frank, I don't remember how to refresh that part of the screen. Sorry, I'm not the AUI expert. I'm just the Blue App guy.
Gotcha.
But Chuck said it best. Those things would just be there. There'd be a playlist there that we could now control and play and do whatever we want. And then the last thing I was going to show was modifying. You could add another cut, and just the fact that you change that playlist, the Blue App would recognize the change and transfer just the file that changed. And if that file was already over there, it would realize, hey, that transmitter already has this audio file. There's no need to transfer it again. So if you use the same files more than once, like the same promos, the same jingles, the same liners, they don't have to get transferred any more than once unless they actually physically get changed. The Blue App will look at the date and time and size of the audio files and determine whether or not they were any different from the last time they were used. So it's very efficient in that way.
And what you're showing right now, Gene, the magic of all this is you're showing a one-to-one relationship between the DAD and the transmitter, but this could literally be 100 transmitters out there, and the process would be the same.
Exactly. So that's the automated control of push radio portion of things. So now Chuck's covered manual. I've covered the automation part. So now we'll I'll turn it back to Chuck and questions and answers.
Okay. Do I have control now?
I am doing that right now.
Okay.
Yep, you have it.
Okay, so if you've got this screen here, let's see if I can make this work the right way. Okay, so you should see the benefits of the push radio model now. The main concepts are that it can reduce the distribution costs. And this is a very, very important point. Many large networks, whether they be religicasters or state broadcasters or educational broadcasters that have hundreds of low-power transmitters distributed over a wide geographic area, they tell me that their number one operating cost every single month is the cost of the satellite. And they could do so much more with their network if they didn't have that every single month satellite cost. So this is a technology which has the potential of getting rid of that satellite cost entirely and replacing it with very low-cost internet coverage, but without sacrificing reliability, because in fact push radio actually improves the reliability. Your net can die, you're still on the air. Sun fades can come along, you're still on the air because the content is actually at the transmitter site. And because I can push out different content to different transmitters in different regions, I can have the weather forecast in this region be the weather forecast for that region, not a kind of a blasé overall countrywide, it's going to be kind of nice today, sunny in the daytime and dark at night. This allows you to be more specific and add localism back to radio. Now, the support of it with regard to Nautel's product lines is the VS and the NV Lite have the beta capabilities in it right now, and the NV and the NX are coming soon. Continuing, we believe that the target push radio client are regional and national networks with many transmitters using a satellite feed. That's where the big benefits come. Potentially educational or religious broadcasters that have block programs. But we want to understand your specific applications. Gene and I have a lot of experience in radio, but we don't know specifically how your network works and what the concerns and problems and challenges that you face are. And if there's ways that this integration between the automation, the studio automation, and the transmitter can help you, then let's talk about it. You can talk to ENCO, you can talk to Nautel, but let's have that conversation and find out how we can tailor this technology to your requirement. So here are the current implementations and our view of the future. Today, the implementation does not allow a segue. Everything is butted. So if you're playing music and you expect the songs to segue, they won't. We believe this system as it exists today is most valuable to stations that have program blocks. And the playlist always starts at the top. That's not a big issue as long as you don't have frequent power failures, because what will happen, the transmitter will come up, know what playlist it's supposed to play, but it'll start at the beginning. So if you have frequent power interruptions, the easy answer is just to use a UPS on that transmitter. And control is always from the head-end automation, not local. This is an actually interesting point, Gene, because there are a number of broadcasters that I've run into that want centralized control. They want to have the head end always have control of their transmitters so that unauthorized, unpaid-for material is not going on at the local transmitters, and this is some technology that makes that possible.
That's right. Inside of DAD, to music scheduling, that's part of DAD, or an external music scheduler that links to DAD, that is where the central control would come from. The people modifying and maintaining those playlists are directly controlling what's going on in the VS. If they know nothing else and they're never given access to the manual methods, which can be secured and everything else, everything would be centralized and controlled.
Yep. The other limitation is that this is a technology which supports automation at the expense of live. In other words, if we're not using the internet for live broadcasting, then by definition, and we don't have an STL and we don't have a satellite, then by definition live broadcasting is off the table. That may not be a problem in a lot of stations, but in some stations it might be a problem. So live broadcast must be recorded and replayed. And we have some ideas of ways to get around that, both in terms of using IceCast and Shoutcast as a real-time choice, or the possibility of packetizing the audio and sending it out as it's being aired live, so that maybe you have a 1 or 2 or 3 or 4 minute delay depending on the propagation time of the internet for maximum reliability, and then putting them all together again automatically at the transmitter side and having them get played out. So it'd be kind of like virtual live. And today, playlists are limited to about 2,000 entries. We must remember that we designed the transmitter first as a transmitter as opposed to a full-fledged automation system. So we spent more time thinking about the reliability and audio performance and things like that of the transmitter rather than having enough control capability. Nevertheless, I think we've done remarkable things with the audio playout capability. So we believe that push radio is a direction as opposed to a destination. We think that this integration between program source content and the transmitter indicates that we as companies, between ENCO and Orban and Nautel and the other companies that we have in our ecosphere, are trying to find ways to make your job easier, more cost-effective, more reliable, and providing better radio to your listeners. And your ideas and your feedback have been critical in making all this happen. These push radio came from your ideas. So we would like to hear from you and what sorts of things we can do to improve radio in your market. So let me see if I think we're pretty close to the end. Yep, time for questions. So let's go take a look here at what questions we may have. It looks like we've got a few of them here, so we'll try to see how many we can get through. WACC in Miami checks in and says, hello and thanks. Will this work with any other automation systems? I think there's nothing that's stopping that from happening. Today, the original work, the groundbreaking work has been done by Gene and ENCO, who's invested the time, so we're going to give them a head start on this. But eventually, I suspect that other automation systems will also be coming to play as well on this as well. There's a gentleman who says that he had to leave, unfortunately, but he wants to make sure that we're going to be able to put this thing up time delayed on the website in its entirety. And the answer is yes, Tim, we'll take care of that. And hopefully by tomorrow sometime, this entire webinar will be available on our website, so you can download it and play it back. It says, what version of firmware needs to be on the VS and NV Lite to do push radio? And thank you for that, Charlie. The answer to that is the most recent version of 4. And the version of 4 for the VS, I believe, is coming out this week or next. So we're very close to being able to do that. It says, I use USB sticks all the time. Could one use an extremely large hard drive? Is there a delay factor in playing back via USB with a hard drive? That's a good question, and thank you for that, Michael. The answer to that question is we have done some testing with very large hard drives. I happen to have a USB drive at home that has about 15,000 songs on it, and the problem is that when you plug that drive into the transmitter takes some time, some serious time, to read the catalog of that and then keep it. And so we believe there probably is a limitation. We haven't determined exactly where that is and or what changes we might be able to make in the system to optimize that. So we really need to understand what type of applications people are going to have and how we can maximize that performance.
Let me add something to that.
Yep.
Part of the question was related to the speed, not necessarily the storage size but more of a performance thing. It is a USB interface, and I believe it's a USB 2.0 interface at this point. A hard drive can completely, any hard drive these days can operate at full USB 2.0 speeds. It's not going to be any better or worse than a thumb drive. Even though you think a thumb drive is a solid-state device and it could be faster, it's not really. It's limited by the interface itself.
And in fact, in our case, the limitation is really the processor speed in creating the directory and handling things. So, yeah, if you get enough entries in there, there can be a significant delay when you try to choose a song to start playing. Our next question is, I can control what input I would point this list to with my transmitter. Specifically, I have a radio reading service that I carry on my subcarrier. I think we have to make very clear that at the moment, push radio is something that only exists on the analog broadcast carrier. It doesn't exist on the SCA. It's an interesting point and an interesting idea, and I think that that's possibly a direction we may be interested in exploring in the future, is providing push radio ability for the SCAs going forward. I think that's a good question. Thank you for that. It says 80% of our programming is live satellite. How is this going to evolve? Well, there's a couple of different ways, and we've talked about them, and I'm not sure that we've covered all the possibilities. In fact, I'm pretty sure we haven't, but we could either use some streaming method, like Icecast or Shoutcast, to send the live programming, or we could have faux live, where the content is actually going out in blocks. So, for instance, if you start a talk show, it's straight up the top of the hour. The automation system could be commanded or programmed such that it takes and records the first minute, sends that first minute out to each of the transmitters, and then say 2 minutes after the top of the hour, it begins playing those. So you're and it keeps doing that in sequence, reassembling those packets, if you will, on the other end. And you could, in essence, have live programming but delayed by a couple of minutes at each of the sites, and this will be another way of doing it that presumably wouldn't have as much audio artifacts as a Shoutcast or an Icecast stream. Any comment to that, Gene?
Yeah, we talked about this a little bit yesterday. We have an internal logger in DAD that is completely configurable by the hour, by the minute, compression factors, stereo, mono, left and right, whatever. We would use technology like that to do exactly what you just said and packetize a broadcast. So we'd have a DAD in its logger mode running somewhere, just recording what the station output is, regardless of where it comes from. Whether it's DAD playing or an Icecast stream or a satellite feed or live material, host and guest mics, whatever, DAD's recording it, but chopping it up into compressed blocks and sending those blocks to the VS, non-real time, but since they're compressed, they're actually going faster than real time. Okay, so you can record a minute, compress it, and send it over and get it there quicker than a minute. So yes, it's delayed, but it's going to let you keep up. You know, if you try to do it in full bandwidth like PCM16, you'd eventually not be able to catch up because there's more overhead in creating the blocks. But the compression will allow you to do that, just like an STL kind of would, but even with less bandwidth than a traditional STL, like using the internet as you suggested.
Yep. Okay, thank you. The next question, does the local audio content depend on having the Orban inside option? If it doesn't, how do you handle the potential inconsistencies of audio levels in the uploaded audio content? Okay, the answer is that the part of the reason that we first developed Orban inside was not simply to provide a cooler transmitter or provide a less expensive audio processor option. It was that when we have so many different audio inputs on these transmitters, on these intelligent transmitters as we're calling them, the problem is that if you switch from one input to the other input to the other input, potentially because of a silent sense, where do you put the audio processor? Where the only place that the audio processor can go in this kind of design is inside the transmitter, because it's got to be following that switch of which audio input we're going to choose. And so that's one of the things that made this all possible, is the ability to take cuts that are processed differently and have different varying levels and things like that, and run them through the Orban side and put them to the modulator and thus to air, without having external ports to go to an external processor and come back in. This is one of the advantages of this. So I would say that, you know, I suppose there's a way of processing and then sending the files pre-processed, but I think that it's likely that peak control and other things wouldn't be managed very well, and I think you'd have an inconsistent modulation scenario in your transmitter. Let's see our next question here. Could Dad set RDS information to drive the Nautel RDS generator directly in this mode? We have talked about that. I don't think it's implemented yet, right?
No, not directly in the push radio interface, but we already talked directly to all of the transmitters that support RDS directly through our Catapult information interface. Catapult being Program Associated Data Catapulter. Okay,
so the answer is that what we would do, I mean, we already have in the transmitters the ability to bring in dynamic RDS information via an IP address port, and so Catapult rather could send that information to that port in each transmitter, and thus this could be solved.
Correct.
Okay. And let's see here, KUNM is thanking us for the presentation. I appreciate that very much. Alex says, what will we need to upgrade in our current NV20 to get the USB backup functionality? That is, there's two things. You need to get the latest software version, and then there's a little USB dongle that has to be added, which I believe this is correct, which takes the USB from the transmitter AUI computer on the front panel of the NV20, and then feeds that into an AES EBU input in the transmitter, and then the rest of it is under the AUI control of the new software. I believe that to be correct. What type of interface does it use? Not sure I understand that question. You got any ideas, Gene? Doesn't make any sense.
No, I'd like to hear more.
I don't know. It doesn't say.
Take that about 10 different ways.
It's a USB interface, I guess, is the question, and it's a USB 2 interface, and therefore it can handle, you know, whether it be thumb drives or the new types of USB drives that you could buy at Staples or Target or whatever that are terabyte type for less than $100.
Although when I heard the question, I thought it was more the interface between the studio and the VS. Like, okay, we're talking about an internet connection, but the type of transmissions are IP, sockets, UDP, right. WebDAV, FTP.
There's a protocol.
Yeah, there's a bunch of protocols that we use, you know, within the Ethernet, you know, set of protocols, and that is the interface. DAD is a Windows program that utilizes all of those things, so that's, you know, many different interface questions.
So basically what happened is that Nautel's engineers and ENCO sat down and said, okay, if you send me this, I'll give you this. and then
Right.
we developed a protocol from that. There's a question about having a SATA interface. We've talked about it. I'm not sure there's a benefit in this particular situation, but it's good feedback, and I do appreciate it. There are a lot of changes that are occurring, it seems like, every day with hard drive standards, and we thought that USB was pretty universal. Other than scheduling a playlist to begin at a specific time of day, is it triggerable now? Yeah, you can choose to start a playlist via a preset. So a preset can create or could cause a playlist to play, or you can start it with a contact closure, or you could start it through the AUI, or you could start it through the ENCO interface. Anything more that you would like to add to that, Gene?
No, that was perfect. I mean, Dad supports live events. You know, people can push a button to do something now, or a scheduled event that says, do this at a specific time. So all of the above.
Bob says thanks for the webinar, and he wants to forward it to some people who would be interested in this. So we will be putting the link on our website, which is www.nautel.com/webinars. That's where probably tomorrow this webinar will be available. And I believe, Gene, you're planning on putting it up on the ENCO website as well.
That's correct.
Okay. In reference to stream broadcasting, are there any plans to use services other than Shoutcast? Most of our stations stream the world, use Stream the World. I'm not familiar with Stream the World. Right today, we support Shoutcast and IceCast, but certainly we're open to looking at other technologies that may have benefits. Let's see, is to analog digital or digital analog? That's a fragment I can't understand. So I think we've exhausted all the questions, Gene. We finally got to the end. Here's where you can get more information about what we've been talking about today and or Nautel in general. We have our Nautel Waves newsletter. Please subscribe. It always has lots of good information in it. You can find all the webinars that we've done, and we've probably got 30 or 40 of them up there on our webpage right now that you can download, you can watch. We have our YouTube channel, which is available, and we have our Nautel store where you can choose any part that Nautel has ever made, because we've never discontinued support of any product. So there's lots of places to get more information from Nautel, and of course you can always contact your Nautel salesperson in your region, or you can contact as well ENCO at sales@enco.com. So Gene, any parting thoughts that you'd like to mention?
No, other than just I thank everybody for their time, and the questions were great, and we'll see you all online.
Very good. Thanks very much, Gene. For Gene Novacek, I'm Chuck Kelly, thanking you all very much for participating, and have a good day.